test, but then they weren't on the test. Okay, so you're going to have a quiz this week, and it will be on there. So we're going to do our notes on it right now. This should not be something that's super hard, but I just need you to really pay attention so I don't have to re-explain it over and over again. Okay, the only reason that your notes are long is because the graphs are big. Okay, so look at number 1. Okay, look at this statement right here. This is a limit. Okay, what it means is, as x gets closer to 1, as x gets closer to 1 from, do y'all remember what the little negative meant when we covered this? The left, very good. From the left side, the y value gets closer to 1. The y value gets closer to 1. Now, what I want you to do is we're going to draw on the graph. What happens at 1 in your graph? Do you notice that your graph is not connected? Part of it ends up here. Part of it ends up here. So, you're going to draw a line. And then you're going to pick the left side of that line. Now, if you're one of my people that does this, okay, the one that's shaped like the L is the left. So I want this side. So if I'm doing my little mini L's, I want to be on this side. Where does this side go to? Is it the 1 or the 3?
1.
The 1. So as I trace from the left side of the line, I want to be at 1. Okay, now look at this one here. It says as x approaches 1, but now I have the little plus sign. So that would be as x gets closer to 1 from the right side of the line, my y value gets closer to 3. Okay, now look back at the exact same graph. Okay, bless you. Here's my line. This is my x equals 1 line. Okay, do your little L's. Okay, this is the right side. So if I'm looking at this, the right is this side of the line. So as I trace my graph in going towards my line, what height is this side at? Okay, my y value is 3. Okay, but that's because that's the right side of the break. So that's why it's a 3 right here. Does that make sense? Yes. So this is what your x is doing. This is what your y is doing. Okay, and then remember that the little minus superscript means left side, and the little plus superscript means right side. Okay, now we're going to do like 1,000 of these, okay? So to make sure that you got it. So look at the example below. I want x to approach 2. Little minus sign from which side? Okay, then x approach 2 with a little plus from the right. So this is the left side. This is the right side. The first thing I want you to do is when x is 2, draw your line. There it is. Now, for my pink line, this is the left side. This is the right side. Because remember, pink is now my new marker. Pretend orange is not even here. This is the left. This is the right. Where is the left side of my equation touching what y value? 3. What is the right side of my equation touching on the pink line? 2. So you're always going towards the pink line as x is approaching 2. But you're either approaching it from this side or that side. Make sense? Okay. Look at the next one. What is x getting closer to for the next 2? Negative 2. So draw a line at negative 2. Okay, I'm going to draw my purple here. So negative 2 is right there. And I'm going to make my graph go a little bit further because it looks kind of like it's cut off. Okay, on your purple line, I want you to mark your left side and your right side of -2. So there's my purple line. This is my left side. This is my right side. Okay, now trace your graph. As I come in from the left side towards the purple line, what are my y's getting closer and closer to? 4. What about as I trace on the right side? So look, watch, I'm down here. I'm tracing closer and closer to my purple line. What is my y getting closer to? 4. Now, do you notice that sometimes they're the same, sometimes they're different? What is the graph for this one that makes them the same? Your graph is connected. It's going to the same place. That's why these are the same. So I'm going to put here both sides f of x approach 4 because graph is connected. Okay, my graph is going to the exact same place. There's not a break in the graph. Versus here, okay, one side was going to 3, the other side was going to 2. So that's how come they came out to be different. Okay, go down to the next graph. So we did 1 and 2 on the first graph. Now we have a new graph. Number 3. What x value am I approaching for the first question? -1. So draw a line in at -1. -1 is here. First, I want to be on which side of -1 if I have the little minus right here? The left side. So this is the left side touching the line. This is the right side touching the line. So as I trace my left side over towards the line, what's my y value? 1. As I trace the right side of my graph towards the orange, what am I getting? -2. Very good. Okay, now go to the next one. This time I want x to approach 2. So draw a line through the graph at 2. I'll put my line right here. I have a left side and a right side of my purple line. But what do you notice about both of the sides? From this side, as I trace towards the purple line, what am I getting closer to? 1. What about from this side? 1. Why did they both come out to be 1? Because the graph is connected. So I would say 1 here, 1 here. Okay, both sides. F of x approach 1 because graph is connected. And remember, anytime your graph is connected, you're not going to have like different numbers on each side. Make sense? Okay, turn the page when you're ready. Okay, Asada, you're watching notes, so you're not confused?
No. I got it.
Okay. Alright, turning the page. Next one. Okay, what is x approaching for number 3? 2. Put a line through 2. 2 is right here. As I approach the left side of the graph at 2, what is my graph going to be touching? What y value? Okay, very good. The left side is here. It's at 1. What about the right side over here? 2. Now remember, this f of x approaching is always going to be a y value. Okay? Okay, number 5. Next one, what is x approaching? Thank you. -3. Put a line through -3. That's over here. As I trace my graph in from the left side, what is my y value getting closer to? -2. What about my right side? -2. Okay, so notice, did it matter that it was an open circle that time instead of a closed circle? No. So open circle rules are the same. So it does not matter whether you have an open or a closed circle, you're still going to get that same value. Okay? Now, let's talk about what happens as x is approaching 4. Look at the graph at 4. What happens at 4 when you see that dotted line? Okay, what kind of asymptote? A horizontal or a vertical? Which way is that going? That is a vertical asymptote. So I'm going to put here vertical. Okay, I have a vertical asymptote at x equals 4. Okay, now remember, all the other little things we've done so far, my x was going towards a specific y value. Like here, it was going towards 1, it was going towards 2. But if you're getting closer and closer to an asymptote, what is my graph approaching if I'm on this left side and it's going to go up forever and ever and ever? Infinity on the left side. Now, on the other side of the graph, this is the right side. What is my graph getting closer to if this side is shooting down towards the asymptote? Negative infinity. So, we're going to write it onto our paper first, then we're going to put it in words. So, look what it says right here. As x approaches 4 from the left, f of x is approaching infinity because it's going up towards the asymptote. But for 4 from the right, which way was my graph on the right side going, up or down?
Down.
Down, so it was negative infinity because it was going down towards the asymptote. Does that make sense? So we're going to write it right here. At a vertical asymptote, your one-sided limits are either equal to positive infinity or negative infinity. If f is going to infinity, the y values are increasing or going up on that side. If f of x is going to negative infinity, that means that your graph is decreasing or going down. Bless you. Does that make sense? So if I'm going towards a number, cool, put the y value. But if it's going up towards an asymptote, you're putting infinity. If it's going down towards the asymptote, you're putting minus infinity. Good on that? Okay, next two graphs. Look at the bottom two. Okay, look at your first one. I want x to approach negative 2. So I draw my line in at negative 2 right here. Question, is there a vertical asymptote on that point of the graph? Yes. VA, vertical asymptote. That means your answer is not approaching a number. It's either shooting up or it's shooting down. If I'm on the negative side, that is the left side. What is the graph doing? Going up or down? So that's a negative infinity. What about negative 2 from the plus side or the right side? It's going up to infinity. Now, if you don't want to put the plus, this is the same. But if you want to put it, that's okay too. So remember, it's up on the right side. And it's going down on the left side. Make sense? Okay, now look at letter G. Next graph. As x approaches 0, okay, let's draw our 0 line in. 0's here. I want to first be on the left side. Left is over here. Here's my function. What is it going towards? Negative infinity. Okay, now look on the right side. What is this side going to? Negative infinity. So notice that they can be going opposite directions towards the asymptote, or they can be going the same direction. Okay, so I'm going to put here both sides going down. At the asymptote. So it is okay for them to be the same type of infinity, or they can be opposite, doesn't matter. Make sense? Okay, turn the page. We have one more type of asymptote to look at. So we did vertical asymptotes. What is the other type of asymptote? Horizontals. Very good. So turn the page. Look at the next one. Okay, when it says that x is going to plus or minus infinity, that means that you are looking at the end behavior of the graph. So do you remember on your little sheet for your test, I told you end behavior is a horizontal asymptote? Okay, so here's what that means. If x is going to infinity, okay, I'm going to be on the right end of the graph. Now, what does this statement say? As x goes to infinity, so on the right end of the graph, what is f of x approaching? 3. Now look at your graph. Do you see your little horizontal asymptote here? And what is my line going to do as it gets closer and closer to that asymptote? It's going to get closer and closer. Can it go all the way up to infinity? When does it have to stop? It can't cross what? Can't cross 3. So what that means is that as my x goes to infinity, my y values are getting closer to 3. So on the right end of the graph, y values getting closer to 3. Now, how do I know it's the right end? Because I was going to positive infinity. Okay, now jump down to the graph right below it. We're going to come back to this one in a second. So come to this graph right here. As x goes to negative infinity, what end of the graph do you guess that we're looking at? Instead of the right end, we're going to be looking on the left end of the graph. So look at my graph. As I trace towards the left end of the graph, where is it going to end up getting stopped that it cannot go past? 1. Because I have what kind of asymptote? A horizontal asymptote. So, on the left end of the graph, y values getting closer to 1. Okay, but remember, that's because I have a what? I have a horizontal asymptote. My graph is trying to go down to infinity, but it gets stuck because it hits that line and it's not allowed to go past it. Okay, now let's do this one right above it. So it says, what about as x goes to infinity? Which end of the graph am I looking at for infinity? The right side. This is the right end. That's the left end. So look over here on this side. Is it going towards a specific number on this side? No, it's going up forever and ever and ever. Up, up, up. And if it's going up, what do I say it's equal to? Infinity. Good. Positive infinity. Because it's just going up forever and ever and ever. Okay, now look at the one right above it. As x goes to negative infinity, which end is that? The left end. Okay, look at the left end of the graph. Does it have an asymptote? No. What's it doing over here on the left end? Going down forever and ever and ever. What do I put? Negative infinity. So if x is going to infinity, you're looking at the right end. X approaching negative infinity, you're looking at the left end. Okay, so we have one more like that. Look at the last one down there. Okay, as x goes to infinity, which end am I looking at, left or right? Okay, this is the right end. So look at the right end of your graph. What is my graph doing as I come to this side? To where? To what number? To, what's this y value? 1. Because remember, this is always going to be the y value. So it's getting closer and closer to 1. Now, does it want to go past 1? Sure. But when it hits that dotted line, it cannot go past it. Okay, now for x approaching negative infinity, that's the left end of the graph. So as I look over here at this side of the graph, can it keep going down forever and ever and ever? Yeah. No. Where does it get stuck? 1. Negative. 3. How low is that? Negative 3. Yeah? Okay, because it cannot go past that line. Now, pretend like this line is not here. Then can it keep going down to negative infinity? Sure. Okay, so look up here to this little blurb. Okay, it says, it is possible for the graph to have a horizontal asymptote on only one side, okay, towards infinity or negative infinity. But it can also have asymptotes that are the same on both ends or different on each end. So is this an example where the ends are the same or are they different? Okay, this has different ends. Because what was the positive infinity end? 1. But what was the negative infinity end? Negative 3. So that's an example of where they came out to be different. Turn the page and I think the next one maybe they're the same. Okay, so now we're going to put it all together. Okay, so you have 2 more left. Look at the top one. Okay, first I want x to approach 2. I see a little minus sign. If x is approaching 2 with a minus sign, the first thing I do is draw my line in at 2. X approach 2. Which side do I want to be on with the little minus? The left side. So I'm going to look on my graph at my asymptote. Here's my pink line. I want to be on the left side. What is my graph doing as I get closer and closer to that pink line? It goes up to which infinity? Positive infinity. Next I have a little plus sign. That means I want to be on the right side. So I do my little L's. This is my right side. I want to be over here. What is my graph doing though? It's also going to positive infinity. It's going up on the left side and the right side of the vertical asymptote. And remember, that's okay. Sometimes they're going the same way, sometimes they're going opposite ways. Okay? Alright, now look at the next one. As x goes to negative infinity, which end am I looking at? Left end or right end? Okay, this is the left end. What are my y's getting closer to on this left side of the graph? 2. And can they pass 2 to go to infinity? No, they get stuck. Okay, what about x going to infinity? Which end am I looking at? The right end. And as I trace my graph here forever and ever and ever, where is it going to keep getting closer to? Negative 3, but it cannot pass through. Make sense? Okay. Next question, it says, is it true that a graph can never cross its horizontal asymptote? Okay, for vertical asymptotes, that is always true. But for this horizontal asymptote, okay, here it is, y equals 2. Does my graph ever touch 2? Look closely. How many times does it touch it? Twice. But do you notice that it touches it in the middle? Where is it not allowed to touch it? On the ends of the graph. Yes? Sure. I did 2 from the left, so here's my line. I stayed on the left side, and my graph here, as I get closer and closer, it's going up. And remember, up is infinity, down is negative infinity. Okay, so for this statement, is it true it will never cross? I'm going to say no. Okay, it will not cross at the end of the graph, but it can cross in the middle part of the graph. So it doesn't mean my graph never can touch 2. It just means out on this end, I'm never going to get to 2 over there. But I could touch 2 over here on this side. Now, let's talk about the negative 3 asymptote. Does my graph ever hit negative 3 anywhere else? No. Could it though? Sure. just not on this end. Okay? One more left to do together. Last one. Look down at your graph. I want x to be approaching 1 from the left. X to be approaching 1 from the left. So I'm going to draw in my line at 1. There it is. If I want to be on the left side of this purple line right here, which direction is my graph asymptoting? Okay, think about left and right, if I'm here. Okay, which side of the graph am I on if I'm going towards the purple line? Okay, think about this is purple, so this is left, this is right. Where's the left part of my graph pointed? Down, negative infinity. Very good. Okay, versus if I want to be on the right side, I need to be on this little chunk of the graph. And where is it going as I get close to the purple line? Positive infinity. Because it's asymptoting down, down on the left, but up on the right. Okay? Alright, now let's look at our negative 5 asymptote. Draw your asymptote in. Negative 5 is here. Label the left and the right sides of your line. This is the left side. This is the right side. For the left side of my line, which direction is it going? Up or down? Up. And what about the right side? Down. Hello? Yes. Sure. Nick, it's for you. She's just going to talk to you on the phone. You don't have to go down there, yeah. She just said she'll talk to you for a second. Okay, so for my left side, we said we're going up, but my right side is going down. So positive infinity, negative infinity. Okay, 2 more left. X to negative infinity, which end am I looking at? Left or right side? Okay, this is the left end. What is my graph getting closer to? What y value? 3. What about on the right end? What is it on that side? 3. Because remember, what's it getting closer to? My little horizontal asymptote. So remember, you can have the same asymptote on both sides, or they can be different. It's up to the graph. Okay? Now, last thing that I want you to do, take a look at your homework. Number 2. We're going to fix it real quick. Okay, this x approaching negative 5. On graph number 2, where is the asymptote at? Is it at negative 5? No, what's it at? So if you'll change that to a 3, and then a 3. Okay? So do it real quick. I'm going to give you like 30 seconds, and then we'll do it and see if you get it right. So negative 3, where the asymptote is right here. Okay, my negative 3 asymptote. Which way is the left side of the asymptote going? Okay, remember, left, right. So the left side, I'm over here. Which way is it going as I go closer and closer? Negative infinity. Okay, now come on the right side. I'm getting closer and closer to the line. What is that side getting closer to? Positive infinity. Okay, now go to your 1 graph. Here's my line right here. This is the left side, this is the right side. Which way is my left side going? I want to be on the left side, I got to be in this middle section. Negative infinity. What about as I come in from the right side? Positive infinity. Remember, you can leave off the positive if you want. Infinity, positive infinity, same thing. Okay, the last 2. X approaching negative infinity, you are looking at the left end. And then x approaching positive infinity, you're looking at the right end. Okay, now if you look really closely, okay, what does it look like it's going to that it can never cross on the left side? 0. What is it going to over here on this side as it gets closer and closer? 0.
How are you doing 0?
Because you're giving the y value, so if it's the x-axis, that's 0. Right? Okay? Now, and then one more time, let me just remind you, does my graph end up hitting 0 somewhere? Yes, where does it hit 0? Right there. But does it hit it on either one of the ends? No. So it's going closer and closer to 0 here, closer and closer to 0 here, but it does hit 0 in the middle, that's okay. Alright, you got it? Okay, good.